We are trying to find the domain and the range of this particular function here. Okay, so what is the domain and the range? We have a set of input data, what we're going to call x. This is what we input into the function, as you can see by this guy here. And what we output is y, or you can also write it as z of x, the output. So that's what we traditionally know as y, and that's like the vertical there. So how are we going to remember what goes where? Imagine you are a lord or a queen and you're looking over your dominion. So domain is horizontal and that is X. This is the domain. And now you're thinking, how do I remember what range is? Range is what you can consider a mountain range. So that's vertical. And that one there is the mountain range. So you can remember that's the y-axis. Okay, so let's start with the domain. It should be everything, right? Like you can input -3 into this function, -10,000, +10,000. So you kind of expect that from your traditional functions, maybe something like this particular one. This range, sorry, this domain would be everything. So we could say that x is an element of all real numbers that you can possibly think of, like 0.1, 10, a million, all of those ones, fractions even, and that it's basically equal to everything. So that is how you would write it for this one here. But there are two ways that we're concerned about that we can break maths. So if you grab a calculator out now, I want you to get your calculator out now, and I want you to put in 3 divided by 0. What do you get? Should be undefined or math error if you're using a scientific calculator. We just don't know. Let's try a different one. If you've got your class pad, in the main function, go 2x divided by 0. What does that equal? And again, unknown. Who knows? Okay? So that one breaks maths. And so our input cannot be 0 in that case. We cannot have a divide by 0. That's rule number 1. Rule number 2 is, for this level of maths, you cannot have a negative square root. So the other one that can break maths is if you have the square root of something like 9. Okay? If you're in the class pad, you want to turn off what's called complex numbers, where they just deal with it and they say that the square root of -1 is equal to this number called I. All right? You're not going to deal with that. You're just going to say it breaks maths. Okay? Because what number times itself, right? What number times itself is equal to -9? You might be thinking, all right, well, just like -3 times -3, but that's equal to +9. So we see that we also break maths. And if you're on a scientific calculator, it will say undefined or error. So those are the two ways here. And if we have a look, we can see that we've got this guy in the middle here. This guy in the middle that has a square root, and the square root could potentially be a negative. So this is how we determine our domain. What we can say is that the guts of it, so the guts of this guy here, have to be greater than or equal to 0. Because you can have the square root of 0, that's like right now, that's equal to 0. Because 0 times by 0 is equal to 0. So it can equal to 0. So we can say that -6x plus 4 has to be greater than or equal to 0. Okay? Now, in solving inequalities, they can be a bit of a pain. So what I'm just going to do is I'm going to make them equal to each other, and then I'm just going to test either side of the inequality. So we'll make them equal to each other. We will solve for them. So I'll just move that 4 over to the other side. And I'll move that -6 over to the other side. And what we can say is that x has to be equal to 4 divided by 6 or 2 divided by 3. Okay, so now let's test a little bit to the left of that. Let's say x is equal to 0. Okay, if we input it into our our big equation here, I'll rewrite it out. We get z of 0 is equal to minus 2 minus 6, 0, plus 4, and then minus 7. So what's that equal to? Well, that is equal to, we don't really need to worry about the outside stuff, but that's minus 6 plus 4. Hold up, we can see that that is beginning to give us a negative sign in there, and that would break maths. So we're going to say that x can't be on the left-hand side of it. Okay, so if this is our solution here, we can't be on the left-hand side of it. So we kind of have to be over here. Okay, so now there's a special way that we write this. There's a special way that we write this. When it comes to domain and range, you have to write it in this way. It's just how you do it. So we say for domain, okay, we'll have, let me try that again. X is an element of all real numbers, and that X must be greater than or equal to 2 divided by 3. Boom, there's one mark. Now we consider range, okay? So we consider the range of this one, and that is how much has this thing moved. So if we plot another function, let's call it f of x, and if we plot this one, I'll do it in blue, and that guy's just equal to the square root of 0. Oh, so the square root of x. That kind of goes like this. So its range, it can be from 0 onwards. So the range, we would write that all fancy like this. Say that it's an element of all real numbers, so like any number you can think of. And then it just has to be greater than or equal to 0. But we do some manipulations here. So first of all, we have flipped our function because we have added a minus 2 at the front. So you can see that minus 2 there. We've added that minus 2. And so now our function does something like this. Okay, so it's been flipped along the y-axis. Another thing is that we're subtracting 7 from it. Okay, so now we can say that, if we keep modifying this, we can say, well, x has to be greater than, and then when we do the minus 7, well, it gets dropped down, doesn't it? It gets dropped down by 7, and it does something like this. So now it has to be less than or equal to minus 7. Okay, so those are our two ways of doing it. We've got the domain and we've got our range. Where y is an element of all real numbers, and y has to be less than or equal to minus 7. There we go.